Hello, my name is Alexandre Clement, and I will be presenting our work on sensory-informed digital mediation for extreme habitats. This presentation is about a translation problem. In digital construction, we are very good at representing geometry, materials, systems, assets, and performance. But future extreme habitats also need to support psychological and sensory adaptation over time. So the question I want to explore is, how can qualitative sensory fieldwork help us identify the kinds of experiential requirements that digital habitat workflows should carry? This case comes from Archispace fieldwork in Erfoud and Merzouga in Morocco. We are not treating the desert as a literal equivalent to the Moon or Mars. Instead, we use this fieldwork as an analog situation where unfamiliarity, exposure, orientation, sensory regulation, and place meaning become very visible. We're framing this work through three different concepts: efficiency, sustainability, and resilience. Here, efficiency does not mean that our fieldwork makes construction faster. What it means is that experiential requirements can be identified earlier before they become late-stage habitability problems. Sustainability is also used in a specific way. For long-duration extreme habitats, sustainability cannot only mean materials or energy. It also means sustaining human adaptation over time. And resilience does not only mean structural robustness. In this context, it also means the capacity of the habitat to help occupants recover orientation, regulate discomfort, and maintain continuity when conditions become difficult. Digital tools are not the novelty or aim by themselves. They are possible carriers of these requirements. This slide makes the gap we're addressing more concrete. Conventional digital workflow can represent geometry, systems, performance, and operation quite well. These are essential layers, but they do not automatically represent how occupants adapt to the environment. What we are calling the missing or underdeveloped layer is experiential adaptation requirements. So, orientation confidence, refuge, regulation, continuity, familiarity, and meaningful variation. The argument is not that current digital workflows cannot ever include these dimensions, but that they are not usually structured as explicit requirements. So the gap is not that digital tools are absent from construction. The gap is that the kinds of informations they carry are often still dominated by geometry, technical performance, assets, energy, and maintenance. Those are of course essential, but in an extreme habitat, they are not sufficient. A person living in a confined or unfamiliar habitat also needs to orient themselves. They need to recover from discomfort, perceive continuity, avoid monotony, and build meaning in the environment. Our paper asks how sensory fieldwork can help define preliminary requirements for these adaptation mechanisms. In other words, how do we move from qualitative field observation to something that can actually be represented, discussed, tested, or mediated through digital systems? The empirical basis is an exploratory qualitative field study conducted in Erfoud and Merzouga. So Erfoud was treated as the main desert edge context, while Merzouga intensified the exposure to openness, to thermal contrast, to visual homogeneity, and to limited spatial references. The data taken was qualitative, so field notes, situated observation, audiovisual documentation, and reflective discussion. We're not presenting a quantitative comfort study, nor a validated intervention, or even a psychometric evaluation. The important analytical move is this. We're taking sensory observations and asking what adaptation mechanism they reveal. Then, we ask what kind of design requirement could support that mechanism in a future habitat. The first mechanism is symbolic safety through legibility. In the field notes, roads, vehicles, guides, boundaries, horizon lines, and human traces repeatedly appear as stabilizing references. So a road was not important only as infrastructure, it became a sign that this landscape had already been crossed, occupied, and made traversable. It suggested that one could leave the immensity that surrounded us. This complicates a simple idea that safety comes only from enclosure. In some moments, open space felt secure when there were reliable anchors. Conversely, enclosed space could feel oppressive when overheated or poorly ventilated. For design, this mechanism is return confidence. In habitat, this could translate into requirements for legible routes, recoverable paths, visible thresholds, refuge points, and clear spatial anchors. So, safety was not only enclosure, it was also the sense that the environment could be read, crossed, and exited. The second mechanism is signs of life. In the fieldwork, cat sounds, crickets at night, birds, roosters in the morning, seeing palm trees, animal traces, and even hearing a distant dog bark all changed the way the environment was interpreted. These were not just pleasant natural details. They suggested that this environment was not empty or inert. They pointed to habitation, occupation, routine, vegetation, ecological continuity, and even distant human presence. This distinction matters for design. The requirement is not simply add nature sounds or simulate earth. The broader mechanism is continuity. In an extreme habitat, having subtle cues of life, of care, of maintenance, activity, or social reachability may help an environment feel more inhabitable. This was one of the most interesting findings for this paper. When we visited the Voth desert structures, one participant described hearing something like the sea while sitting on the steps. It was not a literal beach simulation. This is what we describe as associative multisensory cueing. The familiar effect comes from a combination of sound, airflow, bodily position, materiality, openness, and personal coastal memory, rather than from reproducing a familiar place literally. This would suggest that familiarity does not need to come from full environmental similarity. It may emerge through partial cues that activate associative memory. For digital mediation, this is important because adaptive systems may not need to recreate familiar places literally. They may instead support associative multisensory cueing, so configurable, non-literal cues that resonate with personal or cultural memory while still belonging to the actual habitat environment. The design implication is not to simulate home, but to support fragments of sensory familiarity that can be adjusted, combined, and tested. The fourth finding is that regulation was dynamic. So heat, silence, openness, and enclosure were not stable positives or negatives. Their meaning changed depending on airflow, novelty, control, activity, and access to refuge. For example, heat could become much more salient once novelty faded or when movement stopped. Wind, on the other hand, often acted as a form of haptic and thermal relief. Shade, planned activity, and even the possibility of retreat also changed the experience of discomfort. We also include in this finding, in this slide, controlled surprise and aesthetic mediation. So encounters with animals, observation of wind patterns, or even the Voth structures were not just decorative or incidental. They actually structured attention, created memory, and helped transform unfamiliar space into meaningful experience. The design implication here is that adaptive habitats should not only target fixed comfort, they should support transitions between stimulation and refuge, attention and recovery, novelty and stability. So this is the central idea for the paper. The fieldwork is not used as a list of things to copy. We're not trying to say, because a road felt safe in the desert, future habitats need roads. Instead, we want to translate. The road, guide, or boundary becomes evidence of a mechanism. Return confidence. That mechanism becomes a preliminary requirement. Support legible recovery paths. Then, we ask which digital mediation layer could carry or enact that requirement. For example, augmented reality route queues, semantic path layers, or even digital twin annotations. The digital layer can be an interface, but it can also be a semantic layer in a model or twin. For example, a corridor, a route, or a threshold might be tagged not only as geometry, but as a recovery path, orientation anchor, or a return confidence support. That makes the requirement traceable across design and later operation. This table is the framework in compact form. So each row moves from field events to a design-related construct and then to a possible digital layer. The first row shows how roads, guides, and boundaries are not copied as physical features, but translated into return confident, legible recovery paths, and possible augmented reality or semantic route layers. For signs of life, the requirement is not literal animal sounds, but cues of care, routine, and continuity. For partial familiarity, the requirement is not to recreate home, but rather to support non-literal sensory resonance through sound, airflow, haptic, or media cues. For dynamic regulation, the requirement is not just having thermal comfort, it is having the ability to move between exposure, activity, refuge, and recovery. And finally, aesthetic mediation and surprise suggest that adding safe variation and even shared discoveries may matter for meaning making. All of this, of course, remain preliminary. The value of the framework is that it gives something to prototype, represent, and test. These mediation layers do different kinds of work. Augmented reality and mixed reality can make cues visible in space. For example, adding orientation markers or annotations, return path cues. Ambient media can modulate atmosphere through soundscape, through rhythm, light, or peripheral signals. Responsive interiors can change environmental conditions such as airflow, lighting, acoustic intensity, or refuge states. Semantic or experiential digital twins are slightly different. They would not directly create the experience. Instead, they would allow to organize the requirements, the cue libraries, the feedback, and the adaptation states that the other systems may enact. In that sense, the twin is less a visual replica and more a structured memory of adaptation requirements. So the point is not that any one technology solves the adaptation. The point is that digital workflows can represent and act on a richer set of human-centered requirements. So in closing, the contribution is not a validated design standard, nor is it a complete digital system. It's a framework for translating sensory fieldwork into preliminary adaptive digital requirements. This contributes to efficiency by making experiential requirements visible earlier in design. It contributes to sustainability by extending the discussion toward long-duration human habitability. And it contributes to resilience by framing habitats as environments that should support reorientation, regulation, recovery, and continuity when conditions shift. Limitations are important. This is exploratory qualitative work. It does not generalize to all users or all habitants. The Moroccan desert is of course not treated as an exact equivalent to the Moon or Mars. And augmented reality, media systems, responsive interiors, and even digital twins are candidate mediation layers and not validated interventions. So the main claim I want to leave you with is that sensory fieldwork can do more than just describe experience. It can help define what future adaptive habitat environments need to represent, support, and test. Thank you for your attention, and I welcome any future contacts regarding the information we presented here.